if these two functions are inverse of each other based from this definition that if you take the composition of function of each other, you will always get x in each of the composition. So let's do that. So the first one is we will try to find function of composition g of x. That means your x in here will be the g, and we will substitute it to f. So therefore, this will be equivalent to the square root of x minus 2. I'm going to make use of the positive. Anyway, even if I square the negative, I will always get a positive number. So minus or plus 2. All right. Now, if I'm going to square a square root, this will just be cancelled because 1/2 of 2 is 1. So therefore, you'll have x minus 2 plus 2, which is equivalent to x. So the first condition was set, and it's correct that the composition of the first function would be equivalent to x. Now we will do the second composition, and that will be g composition f of x. So that means our f will be now the x of g. So if you have the square root of x minus 2, we will replace this with x squared plus 2. So you'll have the square root of x squared plus 2 minus 2 because this represents f. All right? And we know that 2 minus 2 is 0. So we will have the square root of x squared. But this means x raised to 1/2 raised to 2. And so it's equivalent to x. So therefore, the two functions are really inverse of each other. And I actually put them on the graph before in the Desmos graphing calculator. So you see that these two graphs are inverses of each other from the line y equals x are symmetrical from this line. And I just separated the plus and the minus. And as you can see, the two functions, the two equations are inverses of each other based from the graph and based from the theory.